right, welcome back, guys. We have Dave Carson again for the second time. Fulmer Heating, Cooling, and Plumbing. We had the opportunity, so we wanted to get it all done. So on this one, we're going to talk about some of the heating and cooling side, HVAC work. Again, his company's out of Newberry, South Carolina, and they handle a lot of central South Carolina work, which we learned going through this that there's really a diverse amount of products that you're able to sell here because of the age of the homes, both new and old. So we're kind of curious. So first thing, same thing again, overeducate, then what can we look for? So heating and cooling, what's the general premise around it? How do they work? Heat pumps?
Sure. As I go into heating and cooling, the biggest misnomer with an air conditioner is that it blows cold air. What an air conditioner does, it doesn't actually cool a space, it removes the heat. So what it does is suck in right through the return, it sucks in the air in a room if it's hot, goes through a process and comes in cooler than the air it's removing. You ever go to your air conditioner at a business or outside your house in the summer, you put your hand over the fan outside, that air feels really hot. That's the heat from inside your house being removed outside and being pushed outside, is the way it works in a refrigeration cycle in an air conditioner. So it doesn't actually produce cold air, it's just removing heat.
Okay, that's interesting.
Technically.
So out of curiosity then, why are the filters down low to the ground? Wouldn't that be more efficient if they were at the top? Like if I look at if I have a 2-story home, 1.5, I have one that's up on the ceiling at the top floor, but it's the smallest one. The other two are much larger down on the ground floor. It seems like you would want to pull that heat from there.
Yeah, from a design standpoint, you would want, if I was designing that home, you'd want more return upstairs. Because if you think about it, and we haven't had this conversation, but does your upstairs get hot in the summer?
Yeah, smoking hot. I work in the loft. They got 2 skylights. I cook.
Yeah, so
my wife's like, leave the shades open. It looks pretty.
There you go. The reality is you should have a lot more return upstairs. Because heating a house is easy, because hot air rises, especially upstairs. Hot air rises, heating upstairs is easy. Cooling upstairs in the south is hard, because you've got to remove the heat that rises from upstairs, from downstairs, it goes upstairs, and then you've got the sun, you've got windows, you've got the roof, you've got an attic, all that's forcing heat inside the house. So upstairs you typically have more return in the ceiling and a little bit less downstairs at the floors.
Okay.
Yeah.
Okay, yeah. All right, so we got a few different types, right? We talked about heat pumps, furnaces, HVAC, which there's a few different kinds of that, radiator boiler, and then we were just chatting about wood stoves right before this, so I'm kind of curious to hear your thoughts on that. But heat pump is probably the most common thing that we see, if I had to guess, all over. So we walked through kind of how they work there, kind of pulling that air out. That was an interesting fact that you said about removing heat to make it cool.
Now, it's not actually taking the air inside the room and pushing it outside. It's taking the air, circulating it through an air handler or a furnace and a coil, and taking the air conditioning mode and taking that heat through the refrigerant and pushing it outside. Without getting too technical, refrigerant is very strange because it's got a boiling point that's completely different than what we're used to. We're used to the boiling point of water, right? It gets hot to a certain temperature, which is hot to our fingers, right? To the touch, the water starts boiling. Refrigerant boils at a much, much lower temperature. And so with that, as it removes heat, that process from a chemical interaction inside the refrigeration cycle, inside a compressor, an evaporator coil going through an expansion valve. Again, I'm not trying to get too technical.
No, please do.
Yeah, it just removing heat, it removes the heat. So the refrigerant goes in a typical air conditioner. Let's just say that one you're going to see if you go to a business today. You see a condenser outside, and somewhere inside, either above the ceiling, in a closet, or in a crawl space, is basically an air handler, or you've heard it called a fan coil. And in there is the main components are an evaporator coil, a blower motor, a blower, and a control board. And real quickly, the condenser outside does exactly what it says. It condenses. It takes refrigerant and condenses it. It's got a compressor that condenses refrigerant. So essentially, in that condenser, that compressor sucks and blows. It sucks refrigerant in and then blows it out the other side. So essentially, you've got liquid refrigerant, leaves the compressor, goes to that air handler. Let's just say it was right here next to us, where this credenza is. So refrigerant hits that evaporator coil. It's in a liquid form. It goes through a metering device. As hot air goes over it, that refrigerant boils. But again, at a crazy different temperature, so it changes from a liquid to a gas. it's still crazy cold, but with the chemical makeup, it boils. And so as the compressor keeps pumping, it goes through that evaporator coil, absorbs the heat of the air that's going through it with the fan, goes back to the compressor in a gas form, and then the compressor condenses it, goes through that condenser, and it gets condensed from a gas to a liquid, and the cycle keeps going around.
Okay.
So it's actually, as that warm air inside the room goes over that cold coil, it changes the form of that refrigerant. So it changes from a liquid to a gas.
Okay. Is this a closed system, or are we pulling fresh air?
This is a closed system.
Okay.
Yeah.
So most of them are closed. It's interesting.
Most of them are closed.
Okay.
In certain, depending on the local codes, you're gonna, especially after COVID, you're gonna see a lot more fresh air introduced to systems because they want to get outside air in to keep it healthier. And it's real simple. You can do it a couple of different ways. Essentially, if the air handler or the furnace was right here, just on the return side, you've got a pipe coming from outside, 3-inch, 4-inch pipe, obviously with some filtration going to the return side. So when the machine's running, it's sucking not only the air inside, it's sucking some air, some portion or percentage from outside, mixing it together and goes through the machine to get conditioned.
That's interesting. Okay. And that, when you say though, like in the post-COVID era, bringing that air in, would that be in your typical home, or are you talking in like multi-family buildings where they're trying to bring fresh air in, or both?
Both.
Really?
Yeah.
So it almost seems like you would want to keep your inside air there. That's interesting.
Yeah, because remember, if it's sick air, then
I guess that's true.
you've got to get it out of there. Hospitals, obviously outside air, gymnasiums, prisons, like in a lot of cases of like prisons, it's 100% outside air. So they won't even, the inside air is literally exhausted out.
Yeah.
And it's fresh air that goes through a very high-tech machine. Because you think about it, if it's in, Baton Rouge, it's got to take air from 110 degrees to 75 to push it inside.
Yeah.
That's a lot of cooling there, a lot of refrigeration, and it introduces that into the building. So, yeah, a lot of big, especially today, commercial buildings are putting in more and more, bringing in more and more fresh air from the outside and conditioning it on the way in, either heating it or cooling it.
That's obviously going to make systems less efficient on especially the cooling side where they're having to bring that.
Yeah, they work hard. I mean, it's a higher, more expensive machine, works harder, uses more energy. There's also things called, this is getting a little technical, energy ERVs. You might have heard energy recovery ventilators. They take outside air, inside air, mix them up, and then introduce them into the space. So you're recovering the energy from the air that you've already conditioned. So if it's 90 degrees outside, it's 70 in here, I need to get some fresh air in. If I just take 90-degree air, my machine has to work hard to get it down to 70. So an ERV, what essentially does is takes 90-degree air, 70-degree air, puts it in a box with a little fan, mixes it up, and then it reintroduces it to the space. So now it's air coming, it's going to be 80-degree air.
Yeah.
You know what I mean?
Okay.
So it recovers some of that energy you've already spent.
Makes sense.
Yeah.
Sounds logical.
Yeah.
I mean, it sounds illogical to do the whole thing. I mean, I get the whole health side of it, but then you're just making it less efficient, which just goes against a lot of things right now.
You got to keep people healthy.
Got to keep people healthy. I guess that's true.
Yeah.
Okay, so now heat pump, and then going into like HVAC. What is there a difference between these two, really?
No. HVAC is just an acronym: heating, ventilation, air conditioning. That's all it stands for: heating, ventilation, and air conditioning.
Okay. All right.
And all a heat pump is an air conditioner that can go in reverse. So the box is everything's the same. It just has an accumulator and a reversing valve. So instead of that flow of refrigerant I was just explaining in the cooling mode, it's got a reversing valve that reverses it. So now heat is being pushed inside to the coil. So the coil now on the inside gets hot versus being cold. It just reverses. That's all it is.
Okay. So then when we dive into all of these like little things like a split, mini split, single split, those are all the same principle.
Same principle, right. Just a different form.
Okay. What about when I was diving into this a little bit, the VRF?
Yeah.
I don't think we'll ever come across that. When I looked at it, I was like, that seems industrial, but
Yep.
Would it all the same stuff?
Yeah. What you're going to see is you're going to see split systems, like I talked about, either a heat pump or an air conditioner where you got a condenser outside, and somewhere inside you've got another box that does the heat exchange. And a VRF, what you've got is it's called variable refrigerant volume. You also hear VRV for variable refrigerant volume. You have variable refrigerant flow. Excuse me, I can't get that word out. So VRF, VRV. essentially, these are very high-tech machines. You've got a variable speed compressor, electronic expansion valves. They can look at a room, and it's typically you see it with ductless indoor heads on the inside, and it can meter the exact amount of refrigerant to that indoor head to heat or cool a space, and tell the indoor fan at what speed to run to produce the optimum temperature to keep that room at whatever the set point is. Much more expensive up front, but they sip energy overall, so the long term there's a benefit. You see them coming in government buildings, schools. See 'em, a lot of school retrofits now are using VRV, VRF.
Okay.
Yeah, government buildings, military stuff. You're going to see it more and more as time goes on,
Okay.
so to speak. And the other unit you're going to see is a package unit.
Yep.
You described it at your house, on a rooftop, or sitting on the outside of square, rectangular type of box, and that's self-contained. It's got everything in there. It's got the evaporator coil, the condenser coil, all the controls, everything's right in there, just the thermostat on the inside. If it's a rooftop, same thing. It typically, sucks air up into it and then blows the conditioned air down. But everything's self-contained in that box.
Okay. All right. So there's no real special piece to it. They just put it in one package.
Yep.
And call it a package unit.
Yep.
That's marketing for you right there.
There you go.
Okay. And you mentioned when we talked about packages earlier, you said something about it being on a crawl space. Is it more efficient with a crawl space or something? Does it have anything to do with that?
It just depends on the part of the country. Right?
Okay.
Some parts of the country here, there's a lot of crawl spaces, so the ductwork is in the crawl space, and the furnace, evaporator coil or the air handler is going to be in the crawl.
Okay. All right. So the crawl space there. Okay, that makes sense.
There's benefits and disadvantages to each.
Yep. Always.
Yeah.
Always was.
Yep.
Okay. So we were talking. Typically in our world, they look for these roof, plumbing, wiring, heating all to be replaced within the last 35 years is usually the rule of thumb for carriers. And you're saying that for most of these right here, you're talking 10 to 30 years of life expectancy on these.
Mm-hmm.
What would be in the 10 range?
Well, they can fail that soon.
They can fail that fast.
Yeah.
Okay. Typically speaking, though, we're probably talking 20 to 30.
I would say in most commercial settings, you're looking at 15 to 23.
15 to 23.
Yeah.
Okay.
Yeah,
That's
if you-
specific.
It's one of those things where if you get to if you see a unit that's 30 years old, it's kind of a unicorn.
Mm-hmm.
You're going to see them, but there's not many.
No.
You get over 30 years old, that's kind of like a Bigfoot sighting.
Okay.
Honestly.
All right, and on the residential space though, will they reach that 30 because
They
they're
will.
lower drag?
They'll-
But
yeah.
it's still a unicorn.
You'll see some, yeah. Oh, yeah.
Still a unicorn though.
Yeah, it's still a unicorn. Because you got to think about, especially with heat pumps, they're asked to run all the time, right?
Mhm.
In most parts of the country today, they're running 10 months out of the year. And you look at a 20-year lifespan of an appliance that runs all the time.
Yeah.
It's got thousands and thousands of hours on it. Well, parts break down. Key parts
Yeah.
break down at some point. Yep.
Okay. Interesting.
Yep.
All right. Well, I'm curious in the 15 to 23. Now I'm gonna have to ask around from some of my carrier buddies and see where the World 35 came from.
See what they tell you.
Yeah.
I mean, you're going to see it. Don't get me wrong, but it's
Yeah.
you're getting it's a Bigfoot sighting.
Yeah. Well, I was gonna say at 35, you're beyond even the 30, which is the subject matter experts' expectation of a long one.
The other piece you got to remember is technology moves fast in every industry. No different here. A 30-year-old machine, a brand new machine today, base efficiency is going to use 60% less energy than a 30-year-old machine.
Okay. Yeah.
So you're going to save all kinds of money on your electric bill just by replacing it. In a lot of cases, we see people, we replace an old beater with just a new base efficiency, and they're like, "Man, I'm saving $100. I'm going to pay for my investment in my air conditioner in 5 years."
Okay. Okay. Yeah, I was about to say ours was 15 SEER rating or something like that. We had
Okay.
14, 15, 16 as the option.
Yep.
I think we did the 15, and it saved the electric side. It saved a good bit, I would say.
Yep.
The gas side, though, like we discussed, it seems to have skyrocketed on that, but that could just be a cost in general. Okay. All right, and then all right, next one. So now we get into the water flow. So radiators, boilers, radiator system. It's utilizing a boiler to heat the water and then running it. Okay.
Mhm.
All right, you want to explain that a
You
little
guys
bit?
see that at all?
What?
Boilers?
So I've actually done a few inspections where we've had like full-on industrial boilers, but
Okay.
that would be for it was for larger scale like woodworking facilities, stuff like
Right.
that. I don't remember what they were manufacturing, but they had an entire concrete block room.
Right.
In the most recent one I did, and he was telling me that he gets it serviced every year. The service is like per his insurance company, he had to get it serviced every year, and he said the service was like $3,000 or something like that. And he said they sent these technical guys. This is very dangerous, high pressure. Actually, I was hoping to find somebody to talk to about just boilers in general, because I thought that would be really cool.
It's we don't see them in the South in residential applications. It's a Bigfoot sighting. You do see it some commercial and industrial where they need very specific. They have very specific heat requirements. And the best analogy is water is always going to be used in some heating and cooling, just because it is the best it's the best mode of transferring heat. And a great analogy is cook bacon on the stove, take the bacon out, burn in a hot pan, put it in your sink full of water. Within a nanosecond, pull it out. It's already changed the temperature, right? That water absorbs the heat from that pan just like that. If you take it out and just leave it on the stove, it could take 20, 30 minutes to cool off, whereas water does it in a nanosecond. So water's a great heat transfer agent. So boilers, I would tell you, you're going to look kind of the same thing as you would for plumbing. Corrosion on the pipes, any water leakage around it. Look at the age of it. If the water is nice and pure and clean that's going through the boiler, they can last a long, long time. You can see boilers 40, 50, 60 years old. Okay. If the water is nice and clean, they're in a clean environment and they're kept up. There's some really neat electric boilers today as technology's gone on. You see more radiant floors. I mean, people are asking us for that in residential settings. And we're starting to get into that a little bit. But on the commercial industrial side with a boiler, just look at the plumbing side. You could do some research online with it too to see that particular model, what the history is, that sort of thing. We don't see many. That's one thing, we don't see many boilers here at all. Very, very.
Are they high pressure?
There's some pressure. Some pressure. Some are crazy high pressure. Some really aren't. It really depends on the system where it's being used for.
Okay, very good. And then so if you're setting up like a radiant heating and cooling system, what type of plumbing are they using on that?
They typically use a PEX. PEX are copper.
Really?
Yep.
Okay.
Yep.
I just assumed it was going to be like some sort of cast iron.
It's a different flavor of PEX, but copper as well. Most of the old radiant floors were copper.
Okay, interesting.
Yep.
All right, and then I think the last one we want to talk about was the wood stoves. We don't see a whole lot of these. They're really a big no-go in the insurance world. Carriers don't want to see them at all.
Sure.
So walk us through kind of like how they work, what they do, benefits, drawbacks. I'm assuming they catch on fire. That'd be a big drawback.
Oh yeah, that's a drawback. You got
the main one.
Somebody's got to carry the wood and put it in there and cut the wood down and everything else. If you've got access to a wood source, right? You live kind of you got some acreage or what have you, access to wood. We do see them, but you just got to put the wood in there right before you go to bed at night. If it's crazy cold, that sort of thing, it needs constant attention, so to speak, because it's manual. But if the wood is free, you're not paying for a gas bill, an oil bill, or an electric bill with it, or a very small electric bill. We don't see many of them here, but the thing we always tell people, there's a million ways to heat your house, right? If you're and I don't recommend all of these, obviously, but if your heater went down in a real cold snap, I mean, you could turn your oven on or turn your burners on your stove. You know what I mean? There's things you can do.
Strike that from the record?
Yeah, strike that from the record.
Don't recommend that.
But people do, I mean, if to survive, you're going to do it, right?
Okay.
You're not going to freeze to death. You're going to turn your oven on, open the door, and wait for your carbon monoxide detector to go off. Right? You can stay alive, I guess, in the most primal form. Air conditioning, cooling, there's only one way to do it. I mean, you can live in a pool or something like that, but air conditioning is what it is to cool the air in the summer in the South. There's only one way to do it. And so heating, there's a lot of ways to do it, but cooling, there's only one.
Okay.
And that's something to keep in mind. Because we see people who will string a heater out and they won't fix it or they won't fix it properly because they have some other, you can plug in little space heaters, things like that.
Those are also a big no-go. We don't recommend those.
There you go. But on the cooling side, there's only one way to cool your house or your building.
Okay. Yeah, because we had, I told you that I only had really one experience actually staying in a place that had a wood stove, and I woke up like 4 hours in with a nosebleed because it took all the air out.
Yeah, sucks all the humidity out of the air, right?
Yeah, but like I said, I would say they put, like 3 logs in a smallish one. I mean, that was the whole night. So, I mean, you do that in a fireplace that gives you 40 minutes, 30 minutes, right? So obviously it's fairly efficient.
It really comes down to controlling the airflow in the combustion air. So less combustion air, the wood will burn slower, can burn a little bit hotter. and it'll last longer.
Yeah. Okay. So that's where it does it. It's just the airflow coming into
Yep.
it. That's how they get the efficiency. Okay. All right. And then actually, you triggered my mind a little bit here. Do you know anything about geothermal? Do you have any experience
We
with
do.
that?
We're the largest installer here in Central South Carolina.
All right. Walk me through geothermal then. I've only seen one house with that in the past.
Okay. You're starting to see it in some commercial industrial applications too. You see geothermal. We did a big building down in Aiken outside of Fort Gordon here a couple years ago. Real quickly, what geothermal does is it uses the solar energy that's trapped in the earth or in a pond or a lake or a pond, that sort of thing, to heat or cool a space. So if you think about the air conditioner that I described with a condenser outside with a fan running, now what happens is that fan goes away, and there's if we have what we'll call it a lake loop, or if we've got a water source in a pond or a lake, now we're taking water from the lake or the pond, and that's what's helping cool the refrigerant to send it back inside. You don't have a condenser fan motor anymore. Your condenser now is very, very small. You're using water to go ahead and be a cooling agent in the process. And if you've got a ground loop, essentially what it does is you've got loops in the ground that can be either be vertical, like a well, or horizontal, and you've got a water, and there's a small amount of antifreeze in it in some locations, where that water runs through these pipes in the ground for hundreds of feet and transfers heat, essentially. So you've got so let's just say water coming out of the machine, 90 degrees, it goes down 300-400 feet, comes back after traveling 8 feet underground. Remember, 8 feet underground is a constant 50 degrees, 55 degrees. Okay. So that water comes back, it goes from 80, comes back at 60. Now you're using 60-degree water to cool your refrigerant versus 95-degree air in the summer. Think about how much more efficient that is.
Not super efficient.
Yeah. And that loop in the ground or using lake water or pond water continues. Really neat technology. It's not that complicated. The expense is putting the loops in. That's the big expense. Either whether it's a well drill. I mean, heck, a well driller here in Central South Carolina, they're about $18 a foot today to drill a well. And so you're looking at, if you've got, mid-size house, 3-4 ton unit, you're looking at hundreds of feet of well being drilled. You could be $20,000, $30,000, $40,000 with just holes in the ground for your geothermal system. The great thing with geothermal today is the tax credits are huge.
Okay.
Yep. 30% federals for about 10 years. In South Carolina, it's right at about 22% for a state tax credit. So combined, it's over 50% tax credit.
Okay.
So if your system, let's just say, cost $100,000, you can get tax credits for half of that. So your real net out of pocket after doing your taxes would be $50,000.
So you're running, because I think when I put in my gas pack, it was like $8,000 total. So you're running 5x.
Yeah.
But your cost is basically zero, I would assume. Very close.
Very close. Yeah. Yeah. What you're looking at is the bigger the house, geothermal makes more sense. Because if you're looking at a $2,000 a month electric bill, let's just say it's some giant house, you could go put in geothermal and run that down from a heating and cooling perspective to a couple $100 a month. And so you're seeing a bigger savings. We do know folks, especially rurally it's a little bit easier to do it. If you've got a nice pond that's 15 feet deep, 10, 15 feet deep with a kind of a constant level, 100 yards from your house, we can drop a pond loop in there, and they're set forever. And that's not expensive to do. So then you're just talking a little 1 foot wide trench of the pipe going in, to the house to where the machine is, and everything else, there's no digging involved. Anytime, lake loop, like here, Lake Murray, our big lake, is owned by Dominion Energy. They allow it. They allow lake loops in there. They have to approve it. They just look at the depth of the water and things like that when they lower the lake. But lake loops, pond loops are a lot cheaper.
Okay. Wow, that's kind of cool. I'm glad we kind of ran into that, because I hadn't thought about geothermal. Because I did a home. I want to say it was out in the mountains or something, North Carolina, one time.
Yep.
Big expansive home, and they had a geothermal system. And I will say it was like a little bit. There's more humidity, I guess I would say. It didn't feel like it was taking humidity out of the air, so it was a little bit like stickier as you walked around. But I mean, it was pretty comfortable. I'd say they were probably running 73 degrees, if I remember right.
It should remove humidity, heat and cool, just like a traditional system. You shouldn't be able to walk in and say, this feels like a geothermal.
This feels geothermal.
They should all feel the same.
Okay, so maybe they just had some windows open I didn't know about or something.
Could have been.
Okay, so hazards, what can we look for? I know you talked about age, pulling off a panel potentially. I mean, what can we look for quickly to decide if these are okay?
Yeah. The best way to determine age is if you look at the data plate on a machine, typically somewhere on there, even if you can, every brand serial number is a little bit different where the year and month when it was made is on there. So you can Google like, you know, Carrier, Lennox, Train, Goodman, excuse me. It'll tell you in the serial number where the year it was made is on there. But typically somewhere on that data plate is a year, okay, in you know, layman's terms that we can see. You can find it there. If that plate is so worn out that you can't read it anymore, if you open any doors, typically that same information is somewhere inside the machine. Okay. At least the model serial number you can find, and you can look that up online and find that information. No different than any other appliance or a car or a truck. Is it clean? You know what I mean? Is there obvious signs that the machine has been not kept up? Cleanliness makes a big deal. From filters, because remember, if that filter is not catching the debris in the air, that machine is, right? Because that air is going through the machine and it's getting caught somewhere inside there, and eventually you'll starve it, you'll kill it. Okay. Same thing on the outside. Is it clean? Are there obvious spots of oil? You know what I mean? A refrigerant's got an oil in it, so there's refrigerant leaks. You're going to see little oil spots where the copper piping is. Look for things like that. Just look at the wiring. Is it neat? Does it still look presentable? Do you see a lot of burn marks? You know what I mean, on wires, things like that. That'll give just an indication of the overall health. Okay. But you know, it sounds so crazy, but filters are a big deal. They really are, because not only is the filter keeping the air cleaner inside the building, but it's keeping the stuff, the gunk, from getting inside the machine. Mm-hmm. So if the air doesn't kill you, it's going to kill the machine if it gets through the filter.
Okay. All right. Yeah. Cleaner machines working less, last longer, so that's always better for everybody. Yep. Okay. Yeah. Okay. And then you were talking about looking. So like, when I looked in mine, I looked inside of the top ventilation, and I could see like some leaves in there. Like, is that a
That's
big
not
deal?
a big deal.
Not a big deal.
Yeah. If there's 8 inches of leaves in there, that could be a big deal. You know what I mean? Because it traps moisture, right? Water can't drain out of it. It can't evaporate off, and it'll start to rust it.
Okay. Yep. All right. So otherwise, though, there has to be some depth to it. It looks like they've been built up for a while. Okay. All right. Anything else come to mind? I'm gonna say we talked about the wiring, looking for any burn marks, any debris inside and around the equipment. So is the area clear? Does it have clear air that it can pull?
Yep.
Okay.
Yep. If you're dealing with furnaces, gas furnaces, just look at the flue pipes. Whether it's an 80% furnace, which has got a metal flue pipe coming out of it, look for corrosion on that. Any leaks, any gaps. If it's a 90% efficient furnace or greater, it's going to have a PVC flue pipe. Just make sure the flue pipes are in good shape.
Okay. All right. And I'm assuming that would go the same for like a water heater, gas water heater?
Yes, exactly.
We want to see all of that? Okay.
Yep.
And we're looking for what are you looking for? You said rust?
Yeah, corrosion. If you see corrosion all over where the pipe's like coming or going from a furnace or a water heater, it's not a good sign. You know what I mean? It's a sign of age. You know what I mean? Something's going to break there pretty soon, probably.
Okay.
Yeah.
Okay, that's good. All right, anything else come to mind? I think that was all I had for you.
Just on the air conditioning side, big push in technology, big push for heat pumps. You're going to see more and more variable speed stuff. Variable speed compressors, variable speed indoor fans for comfort. They use less energy. Essentially, when you look at a ductless unit, you know, a lot of times when you're in a room with a ductless indoor head, that fan speed will come on and will ramp up or down without you having to do anything. Mm-hmm. A lot of the newer systems for homes and businesses do the same thing. Okay. So if you set it at 80 degrees, it might not shut off all day, but it's going to ramp up and ramp down to keep that temperature right where you set it, and it uses a lot less energy overall than being the start and stop, right? 100% on, 100% off, 100% on, 100% off. It'll just run 50% all day. That's kind of where the sweet spot is in comfort and in energy efficiency. You're going to see more and more stuff going that way.
Okay, yeah, because whenever we bought our combo pack, that was one of the things, was it runs more. Right. I thought that was going to be terrible, and the guy was like, nope, very efficient, keeps the air cooler. Yep. Going through, I was like, okay, makes sense. Well, perfect, man. Well, I appreciate it.
Thank you, appreciate it.